Okay. All right. So, welcome to week 3, everyone. I hope everyone's having a good day. We're just going to kind of hop right into it and continue on where we left off. Um, Last week we spent a good amount of time kind of honing in our sketches. We got a lot better at sketches, I hope, honing in our abilities there. Because sketching and stuff like that is a really big majority of what we do in CAD. So we really emphasize sketching because it's kind of the foundation. So with all of the new knowledge you have of that, we're gonna kind of continue on with some more advanced sketching techniques. Just we're gonna kind of get into some, minor reverse engineering, and then we're gonna cover assemblies, which is a pretty cool thing. Okay, so for the first thing, we're gonna just hop into assignment 7, which is just kind of reverse engineering the engineering fountain at Purdue. So in the Discord, there's a nice photo of the engineering fountain, kind of getting a nice side shot of it. And then we're gonna kind of make our own, take of the engineering fountain. So if you go under resources, there's this image here. Just kind of download it. When you do download it, make sure it's like a JPEG or like a PNG. Sometimes people accidentally download it as like a WHEP file or something like that. And Fusion can't really recognize those kinds of files. So if you download it in that format, you might have to use some kind of online converter or something just to turn it into a PNG or a JPEG, or you can re-download it as a JPEG. But when you do that, we're gonna kind of upload it into Fusion to kind of reverse engineer it. I'm guessing everyone's downloading it right now, so I'll give everyone like a minute or something, get that sorted out. Okay, so I'm assuming everyone's downloaded it. So basically, what we're going to do is we're going to want to put it into our Fusion environment. So normally we kind of default to creating a sketch or creating planes. But this time, before we do that, we're going to add a canvas. So, there's this image icon here, or you can go under Insert Canvas. You can kind of see an example of what canvases are used for. In this case, we're reverse engineering something that exists in the physical world. But sometimes people might draw something like concept art for cars and stuff like that. And then they'll do like front, side, top, back views. And then they'll kind of sculpt a model using those references. So, it's a very cool way or use case for canvases. But you can also take pictures of things, around you. Like if you want to make, a holder of for something with like a strange geometry, you can take a picture of it, upload it to Fusion, and then you can design a part to fit around it. So, yeah. You're just going to want to go to Insert Canvas. It's going to ask you to insert something, a file. So then you just find it on your file explorer and then you select a face. So you just have to kind of select some plane that exists. In this case, I'm just going to select the front face. You can see when I zoom in, we have this engineering fountain here. Looks good to me. There's a bunch of settings that you can change. This slider here is the canvas opacity. So if you want it to be more or less see-through, you can change that. This, I usually leave it at 50, but you can leave it at whatever your heart desires. You can also change the scale and stuff like that, or even the position of it. If you look really closely, you can see, this image isn't perfect. The engineering fountain isn't perfectly centered, so you can see there's kind of an offset here. In our case, it doesn't matter too much, just because we're going to design one engineering fountain, and then we're going to pattern it just like we, you know, pattern the gear and stuff like that. So we're just going to copy one geometry. So I'm not super worried that this isn't centered. Also, my mouse died. That's very unfortunate. Okay. All right. So I'm happy with this. I'm going to press OK. I'm going to see me CAD with a trackpad today, I guess. Okay. So I'm going to create a sketch. It should be on the same plane that we created our fountain. So I select this one here. And then I'm going to just start sketching. So what I'm going to do, I'm going to create just a rough outline of the engineering fountain. It doesn't have to be perfect. We're just trying to get in the ballpark. I typically start with the vertical lines and horizontal lines just to give it some kind of structure here. You can also show and hide the canvas with this little eyeball on the left side. So you can kind of see what I have here. And then we need to kind of recreate this curve here. If you didn't know, a fun fact about the engineering fountain is that this curve here is not actually, just kind of some radius. It's modeled after the e to the x function. So you can't really replicate this with just an arc. So to kind of copy this geometry, what we're going to use is a fit point spline. We used it for the wire on the hairdryer assignment last week, but we can use it here as well. I drew those lines first because it kind of gives us a nice start and end point to kind of reference. So I'm going to use those points and I'm going to click my way down the engineering fountain. One of my recommendations for this assignment is making a point here at the end of this piece and one at the end or at the start of this piece. So you're going to have one continuous spline, and then you can trim away the excess later. So I have that fit point spline. I'm going to start at the top, maybe click a spot in the middle, and one here, one there, one there, and let's say about there. So that looks good. I'm going to press the check mark to confirm it. You can kind of use these adjusters to make it look a little bit closer. Looks good to me. Okay, so we have this nice geometry here. Looks pretty close. Maybe just move this a little bit. Okay, that looks good. So we have this here. We have these 2 points that I talked about earlier. What I'm gonna do is gonna add vertical line here and there. And then I'm gonna use the trim tool over here to cut away at the axis. So with that, we should have 2 fully closed bodies. You can see when I hover over them, they're completely highlighted. I'm not going to bother constraining these for this assignment, so I wouldn't worry about it too much. But you should have something that looks kind of like this. Does anyone need a little bit more time on this?
Yeah, just a
Can
little bit.
yeah, can you show how you got rid of the space in between again?
The trim tool?
Yeah.
Okay. So for the trim tool, you want to make sure, you have these vertical lines first. So, I created those points there and there. That kind of overlaps with this point, at the end of this one, the start of there. Once you have those in, starting at this point, ending at the bottom line, you trim it with the trim tool. Share these scissors up here. The hotkey is T, so if you like hotkeys, then you can use that. Yeah, you just kind of hold left click and run your mouse through it and trim away. Sometimes when you trim splines, then like these things kind of go crazy. You see a bunch of green lines. But the green lines aren't your actual geometry. It's the blue lines or the white lines or black lines that actually matter. These are kind of like the adjusters that look kind of chaotic.
Due to the canvas.
What about the canvas?
So what did you do to it? It's not there anymore.
Oh, it's you can hide and show it with like the eyeball tool up in the left side.
Okay. Thank you.
Okay. So once we have this, you finish the sketch, and then you go to extrude it. So I'm going to select both of these profiles, and then I'm going to extrude it some distance. I don't have my mouse. Okay. So I'm purposely going to do it wrong, similar to, the thing I did last week, where I made the hair dryer incorrectly and I fixed it later. What you're going to want to do is you're going to want to make this symmetric, but I'm purposely going to do it one-sided, just so you can see what happens. So I just set it to 1. You can change it to whatever number that you want. So we kind of have this here. We're going to want to pattern it, right? Because the engineering fountain has 4 of these. So I'm going to create a circular pattern. So similar to how we were doing it in sketches, you can do it to bodies and stuff like that as well. So, you can do it to features or bodies or whatever. In this case, I'm doing bodies. I'm going to select these 2 because we're patterning this. And then the axis, I want it to be this one here. I want 4 of them. and when I confirm it, it generates them. But this does look a little bit weird, right? If I go on a top view, you can see these kind of aren't really centered on each other, right? They're kind of at this weird offset, and the fountain doesn't look like this in real life. So what we're gonna have to do is we're gonna fix this. If you didn't do a symmetric extrusion already, the reason why this happens, you can see this red line here, and that's kind of where we drew our sketch, right? And that's where we're extruding from. So you can see here that we're extruding from one side only, but our axis of symmetry, or like where we're patterning everything, is the origin. So it'll kind of create this strange offset here. You know, in some cases, you might think this is a good thing, right, for your design. It very well could be. But because we're trying to replicate the engineering fountain, it doesn't really look like this in real life. So we're going to need to go back and fix this. So what I'm going to do is I'm going to edit the original extrusion I made. So it's right here in the timeline. Right click, edit the feature. And then instead of one side, I'm going to change it to symmetric. And when you do symmetric, if you want the same width, you just have to divide your original number by 2. So I'm going to do 0.5. I'm going to press OK. And now when it regenerates that circular pattern, you know, this looks a lot more correct, right? It's all centered. It looks nice. Does anyone have any questions about that? No questions. Okay. So the next step for the engineering fountain is to kind of recreate this texturing / detail here. You can do it a couple of ways, right? You can kind of delete the circular pattern and then work on it and then redo it. Or you can kind of manipulate the timeline again. You could, you know, CAD everything and then move the circular pattern to the front like we did for the hairdryer last week. Or you can kind of do a little bit of both, where you kind of roll back the pattern and then edit it. So I'm going to roll it back just to eliminate any dependencies. Sometimes when I do it in like a different order where I pattern it and then I extrude things and modify things and then I try to move the pattern, some people accidentally select the wrong body, right? So if you were to not roll this back, you would want to edit the original one that we designed. So we're going to add, you know, detailing to this one that's not highlighted blue, or I guess right now here is the original one, which is one that needs the details. If you added details to one of the patterned ones and tried to move the pattern to happen after the details, Fusion won't let you because you've created a dependency, right? Because those details would be dependent on that circular pattern. So instead of worrying about that, I'm going to kind of temporarily delete it by rolling it back. So you can see this vertical line here on the timeline. If I hold it, drag it one icon left, I let go, you can see this is kind of grayed out and it doesn't show up here. So the cool thing is we can edit this and then we can roll this forward and all the changes will be applied to the circular pattern, right? The circular pattern is copying the body, so you know we're modifying the body now, and then when we pattern it again, or you know roll this forward, all of the changes that we made will be applied to it. You know, this might be different if you had this, you know, patterning a feature, but in this case, because it's a body, it'll copy everything. So what we want to do here we need to add some detail. So I'm going to create a sketch. In this case, I'm going to just select one of these faces that we have had before. And then I'm going to show my canvas again, kind of give us an idea of what we're working with. And then I'm going to start recreating that geometry. What I'm going to do first is I'm actually going to project these faces onto my sketch so I can reference them. So I'm going to press P. I'm going to click on these two. Press OK. If I hide the canvas, you can see there are these nice pink lines or purple lines that we can use as references as kind of the edges of our parts or our details. But now we need to draw these details. So I'm going to use the fit point spline tool again, and I'm going to start and end on these these projected lines that we've created. So, it doesn't have to be exact. Again, you can just kind of do what your heart desires. This looks fine to me. I'll make more over here. This looks good. Now notice, because I started and ended the splines on the lines that we created, whenever I highlight my mouse over these areas, you can see there's now 4 separate sections, right? 4 separate closed bodies or areas that we can manipulate. So we're gonna use this bottom one and this bottom one, and we're gonna cut it into our fountain. Is everyone here, or do people need a little bit more free time or more time? I can wait like a little bit, just in case. Okay, so this looks good. I'm gonna finish the sketch, and then I'm gonna cut these into the fountain for the detail. So I'm gonna make an extrude. I'm gonna select these two, and I'm gonna make the arrow going that way. The operation set to cut because I'm getting rid of things. And when I do that, we have some little details. Looks good. Anyone need more time on this?
Could you show that one more time?
Sure. So for the sketches, you should be able to highlight the individual areas because that signifies that they're closed bodies. If it's not for some reason, then it might be because, one of your 2 endpoints may be either close to the edge, but not quite, or it's just, not there at all. So you want to make sure you have some kind of endpoint going through your projected lines. You can use the coincident function. Once you do that and these, are highlightable, you want to exit the sketch. And then you want to extrude. So I'm going to select this one and this one. And then the arrow is pointing kind of to the left for me. But I want it to cut into the part. So instead of for the distance, I have to make it a negative number. And for me, I think 0.2 was like a good amount. Does that make sense?
Yep, thanks.
Okay, cool. Okay, so I guess I'm going to try to be a little interactive today and ask you all a question. We kind of want this engineering fountain to be symmetrical, right? We want these details to be symmetrical. So there's a couple of ways that you could go about doing this. You know, does anyone have any thoughts on what operation that one should use if they want to kind of make this geometry on both sides? There's more than one right answer, so yeah. Feel free to unmute yourself or, throw something in the chat if you are feeling
Maybe
shy.
you could create an offset plane so it's in the middle of the piece, and then from there you do a two-side extrusion.
You could do that. Yeah, that is one way you could. Any other thoughts? That's a perfectly valid way. So, but I'm curious to see if anyone can think of other methods. Let's see.
Can you hear me?
Yes, I can.
Yep. How I would go about it is I would create a cross section plane down the center of it, and then mirror the feature across that plane.
Okay, yeah, that's also a good idea. That's honestly what I would do in this scenario. But the other suggestion was also very good. I think because in this scenario, I want them to kind of be identical. I'm, at least for me personally, I'm more inclined to mirror things. Just because if I need to edit this one side, then it'll make sure the other side is also, extruded the same amount. But for another scenario where you might want these to be different sometimes, creating that offset plane and then extruding it afterwards, like the first person said. I didn't quite see the name, but that would probably be the way I would choose if they were both, susceptible to being different amounts of extrusion. But you can still do it in this for this assignment as well. They're both perfectly valid. So what I'm going to do, I'm going to do the mirror thing. So I'm going to create a mirror. And again, you can create mirrors in sketches, but you can also create it, on bodies and stuff like that. So I'm going to do a mirror. For the object type, instead of bodies, I'm going to change it to features, right? So I'm going to mirror, that extrude feature that we did. It'll ask me to select an object. In this case, it's the feature that we want. So I'm going to click on that one in the timeline, or I believe you can click it here. Yeah, you can click it on this, on the body itself. And then for the mirror plane, because we have a symmetric extrusion, there we have a nice plane going down the middle. So I'm going to select that plane. And then when I confirm it, it should cut away. Yeah. So that looks pretty good. And again, the reason why I would mirror it in this scenario is because, for example, if I wanted this to be different, maybe like 0.1 instead, when I make that change, it applies it to the other side. So I want it to be symmetrical, but if it was supposed to be asymmetrical, you can do other methods as well. Another valid way of doing this is by creating another sketch and then projecting like this extrusion that you created. So like, you know, you could create another sketch on this side and then you could project these two. And then you can extrude it. You know, like that. Like in this case, you know, now they're asymmetrical because you can specify different amounts of extrusion. So that's another way of doing it as well. And again, there's no like, you know, there's no wrong way of doing this, right? Everyone has their preferences. So, you know, if you're not doing it the same way as me, that's totally okay. As long as the geometry that we're going after is, you know, kind of the same. But yeah, this looks good to me. The cool thing now is if
I have a question.
Sure.
When you were mirroring it, what if you only wanted to mirror like one of the extrusions and not both?
If you wanted to mirror one of the extrusions and not both, that's a
Yeah,
good question.
because the thing automatically selects both of them.
Yes. So the mirror feature, when you mirror the feature, right, it's mirroring everything that you did in that one operation. So, for example, or in this case, like we extruded both of these sketched areas at the same time. If you wanted to mirror them individually, what you would, or what my recommendation would be to have separate extrusions for each one. So, you know, you would have one extrusion for this piece and then one extrusion for that one. And then when you mirror it, you can specify that you're just mirroring this feature that houses that sketched area instead of both of them. Does that
Okay.
make sense?
Yeah.
Okay, cool. You can also do like the whole like projected sketch thing and then extrude it. But instead of projecting both of them, you can just project one. That's also valid. So yeah, there's a bunch of different ways. But yeah, now that we have this geometry, because we have our pattern from before that was rolled back, if we roll it forward, you can see it applies all of the stuff that we've been working on to the rest of them. Right, so now they're all identical, all have details, and it looks nice. Does that make sense? Okay. The last thing for this assignment is just to add a base to it. So I'm just gonna create a simple sketch here. The nice circular base, get like 15. And then I'm gonna extrude it. I'm gonna make sure I select this as well. Oh, it's kind of big. So, oh, the sketch needs a hole at the center. Yeah. So I'm gonna edit the sketch and I'm gonna add that hole here. Oops. There we go. But yeah, that should be the engineering fountain assignment. Does anyone have any questions about this?
But could you go over the circle extrusion again? The sketch on the extrusion?
The circular pattern?
Yes.
Sure.
No, not the circular part in the extrusion at the bottom.
Oh, this one?
Yes.
Sure. So I'm just gonna rotate onto the bottom. I'm gonna create a sketch, and then I'm gonna select one of the faces. These are all kind of on the same face, so it doesn't really matter. You can click on this one or whichever one. And then you just create two circles, one large one, and then one smaller one. So this looks good. And then you extrude it, which is right here. And then when you extrude it, you need to make sure you specify this closed area, but also this one. I believe like Fusion will default to kind of have this section that you selected for your sketch as an option to extrude, or just like a closed body to extrude. So you have to specify both. Specify some distance. I did 0.5. That looks good. Did that make
Why don't we
sense?
use the whole function? It's not just optional.
I mean, you could use the whole function. I mean, in this scenario, like, this isn't really a specific drilled hole. So, like, this is just kind of a model of the engineering fountain. But you could use the whole tool if you want to. That's perfectly valid.
Okay.
Yeah. I typically use the hole tool when I'm specifying, like, specific drilled holes, like clearance for, M3 bolts or, countersunk M5 or something like that. For like just round geometry that's not a hole, then I'd be more inclined to sketch it into whatever I'm designing. But that's just a personal preference.
Could
Any other
you go
questions?
over again cutting the details out?
Sure. Did you complete the sketch already and you just don't know how to extrude it?
I only extruded it on one side. I don't know how to get it on both.
Okay. So you want to mirror the feature. Okay. So I'm assuming you're about here.
Yeah.
Okay. So you want to go under create, then mirror. And then for the object type, you want to select features, because we're going to be mirroring a feature and not a body. It's going to ask you to select an object. You can click on the area that was kind of extruded inwards, or you can go into the timeline and find the specific feature extrusion, right? So in this case, the extrusion is here. So I'm going to click on it. And then you specify the mirror plane. So you click on that. If we look from the top, right, we have that symmetric extrusion. So this kind of red line is going through the middle. There's a plane here. We're going to select this. And then the compute type should be identical, but sometimes it doesn't work. So, if identical isn't working for some reason, you might want to try one of these, like adjust or something, and it might work out for you. Sometimes it used to be a lot more buggy. I think they kind of fixed that now. But then once you press OK. It should look like that.
Yeah.
No problem. Okay. Any other questions on this assignment? It's not happy. No more questions? Okay. So, I'm going to save this real quick. All right. Now we're going to go on to assignment 8. Okay. So, up to this point, we've mostly been working on single body parts, right? You know, what we just did. We just did the engineering fountain. It's one body, it's one part. Hair dryer is all one piece, right? But in the real world, a lot of the times you're going to be making things with more than one part, and they kind of need to interface together, right? You know, you've put things together. You know, your phone or whatever is made of, you know, hundreds of parts, sometimes thousands of parts. You know, everything you interact with is almost always more than one part. So engineers or people who design things kind of need a way to simulate all of these parts being put together before they actually make it, right? Doing this on the computer kind of allows you to troubleshoot and work out any issues before you actually make it. So what we're going to do today is we're going to be building some Lego, you know, in Fusion. So we're going to be assembling this Lego car here, just so we can, you know, get a nice feel for assemblies. So yeah, on the Discord, there's this zip file with, you know, all the Lego car components. What you're going to want to do is you're going to want to download it and then extract it, extract the folder, and then we're going to upload it to Fusion. So I'm going to download it. I swear it's not a virus. Go into your file explorer. Extract all the files. And then we're going to upload it to Fusion. Move this real quick. Okay, so for this assignment, I typically like making a new folder just so everything stays a little organized. So I'm going to go into that. I'm going to select upload. I'm going to find the files. Just Control A or Command A. Going to upload all of them. We're going to wait a little bit. Is anyone having trouble downloading this at all? Hopefully not.
Can you show how to upload them again? Like after
Um,
you've extracted it?
yeah. Are you able to open your data panel? Like, do you see this on the left? Okay.
No.
If you don't see it, like next to like kind of the house icon, there's this like array of squares. If you click on it, it should open kind of like that side folder area.
Oh yeah, I see it.
And then you can go under, you can make a new folder and then upload it there.
Let's see, upload or create a new folder. Is there somewhere else I can go to do that?
Did you open the data panel? It's right next to the home button. There's this like array of squares. It should open up this kind of area here.
Yeah, it doesn't show me that even in the data panel.
Does it look like this?
Yeah. Then I clicked on my recent data.
Okay. I recommend you have like a project. So you create a project and then put all your assignments in there. So for me, like, you can hit new project or something. Oops. You can hit new project, you can name it something, for me, I have like milestones CAD class here. And then in there, I have folders of stuff. So that's where you can create folders and stuff like that. I'll give everyone like another minute to get all of their files in order. Okay. So now that I'm assuming everyone has their files uploaded, I'm going to create a new file. In this case, I'm going to do an assembly because I want it, we're inserting a bunch of different parts. And it'll kind of drop us into this assembly workspace. The first thing I do is I save the assembly file. I don't know if you have to do that anymore. Oh, you don't. Okay. In the past, Fusion made it so that you had to save the file first before you can insert parts into it, but I guess that's not a thing anymore. I just kind of got into the habit of doing it. So make it, I'll save it, and then I'll insert my first part. So for this assignment, or for assemblies in general, you typically kind of want to insert the first part. Well, I can't talk today. You kind of want the first part of your assembly to be a nice foundation to whatever you're designing. So, if in this case, we're making a Lego car, I wouldn't really use like the tire as a nice foundation, because that's kind of a more secondary part or tertiary part. So I would kind of think of it as like, having a foundation or like some kind of frame piece as your first inserted part. And the reason I recommend that is because the first part you add into an assembly, it by default is grounded. So if you remember like the fix/unfix constraint, grounded is kind of the assembly equivalent to that. And the first part always needs to be grounded, just because you don't want all your parts flying around arbitrarily in space. So when you insert your first part, Fusion will default it as grounded, just to make sure it doesn't move. So it typically centers your part on the origin, and then you can build or assemble things on top of that, if that makes sense. So, to me, for the Lego car, the more foundational piece to this is the largest piece, which is this kind of 2x6 plate that runs across the whole car. So I'm going to go in my data panel here. I have that 2x6 plate. You can drag and drop into the assembly, or you can right click and then do insert into current design. They both do the same thing. What you can see here, it kind of places the Lego brick, near the origin. So this looks good to me. I'm not really going to mess around with its position. So I'm going to press OK. If you want to confirm that something is grounded, you can kind of see here in the corner, there's a little anchor on the component icon for this plate, right? And that means it's grounded. So if I right click it, you can see I can unground it, but I don't want to in this scenario. So this is our nice foundation, but now we need to add more parts, right? So I'm gonna start with this axle piece. What I like to do is I like to move the part to be kind of away from where its final resting place is going to be, similar to how I like to sketch things like quote unquote imperfectly and then constrain them later. I like to do the same thing for my assemblies, right? And that's mainly to just confirm that when I add a constraint that I'm putting it in the right spot. So this looks good to me. So we have these two parts. They're not connected in any way. I can even move this part. But what I want to do is I want to add a constraint to make sure these can't move. So there's this constrain components function or tool here. And there's a couple of ways you can go about doing it. What I like to do is I like to add 3 constraints, or kind of combine constraints into one, or 3 constraints into one. So if you remember from week 1 when we did the hammer, you saw how, or you might remember how I created 2 different fillets, like 2 different radii fillets in the same quote unquote like fillet function. Like personally, I like to do that because I think it cleans up the timeline a little bit. And I like to do a similar thing when it comes to constraining my things in assemblies. So you can see here, there's this like kind of simple component, or like this align component constraint tool, but then you can see there's this plus button, right? So what I'm going to do is I'm going to create, one alignment constraint, and then I'm going to create two more, right? Because we're working in a 3D space, so we need to align these parts in three different directions. So in this case, what I like to do is I like to constrain through the studs, but there's, you can constrain multiple ways. You can constrain on the faces. So I'll kind of do a combination while I create some of these constraints. So I'll first start doing the stud method because I like it for this assignment. Basically, I'm going to select one kind of face or edge or something on one component, and then I'm going to select a corresponding face or edge or something on another component. When I'm working with assemblies, I typically avoid using edges as much as I can, especially when they're parts that might change. And that's mostly just because, when you are making an assembly, sometimes your parts aren't fully fleshed out and finished. And when you finish your components, kind of the last thing you kind of like to do is, make it pretty and nice and add a bunch of fillets or chamfers everywhere. And when you do that, the edges that you may have selected for your constraints will disappear, right? Because you created a fillet where the edge used to be. So I typically like to make sure I'm using faces as much as I can, just because a face typically doesn't change as often as a edge, right? A face may extrude more or less based on your design, but it typically doesn't get fully covered up. And if it does get fully covered for whatever reason, then you probably made some major redesign and you need to remake your assembly anyways. So that's why I typically use faces. So in this case, I'm going to use this face of the cylinder, right? This outer face. And I want this cylinder to be aligned with this cylinder on this stud, right? So I'm going to select that and then that. It might move the component a little bit. So in this case, it's kind of phasing through the part, which is not what we want, but we can start adding more constraints to fully constrain it. So I'm going to add another constraint here. There's this plus icon. You can see when I enter in the second constraint, it'll gray out one of the parts. So it typically grays out the part that you selected second. So I selected the kind of main 2x6 plate first. So this doesn't gray out, but the other one is grayed out, right? It's transparent. Basically, it's just asking you to select a geometry on the first component, right? So in this case, I want to align, these studs diagonally, but you can pick another one. I just like doing it diagonally. So I'm going to select this face, and then you can see it flips and changes, or it makes the plate transparent, and then it makes this axle piece, solid. In this case, the corresponding cylinder or the corresponding stud for this is already kind of in the right spot. So it looks like I'm clicking in the same area, which I kind of am, but I'm selecting it on this component instead. So I do that. It's already kind of aligned. So the next thing I'm going to do is I'm going to add a third one, right? So it's constrained, here and here. So if you think about it, there's kind of like an axis going through the center of this stud and this stud. If I confirm it, you can see it just goes up and down. It can't spin around. So I've constrained it in 2 dimensions, but we need to constrain it in all 3. So I'm going to edit this constraint, and I'm going to add a 3rd constraint. And this time, I'm going to select the bottom face here, right there, and then this top face here, because I want them to kind of butt up against each other. So when I do that, these 2 components have now been constrained in 3 dimensions. You can see if I try to drag it, I mean, you just see my mouse moving, but I'm holding down left click and I can't move this component. And it's because, it's fully defined in all 3 dimensions. So that looks good to me. Does anyone want me to do it again? I'm guessing the answer is yes.
Yes.
Okay, cool. Yeah, I'm gonna do a couple more. You can kind of follow along. Hopefully you get kind of a good feel for it. I recommend you don't do any of the wheels and tires yet. I'm gonna cover that in just a little bit. All right, so I'm gonna do the front axle here. So drag this in, kind of just moving it around. Again, it's not in a perfect position, but that's okay with me. And then now I'm gonna constrain it. So open the constrained components tool. In this case, I'm gonna do these faces first. So I'm gonna do the top face there, and this bottom face. Hopefully there's a little bit less phasing if I do this. So that looks good, right there. They're nice and flat against each other. I'm gonna add another constraint. You can kind of see, it's kind of hard to see, but you can see there's like a cylinder here and a cylinder here, right? The top of the stud. I want these 2 to line up. So I'm going to select this stud here and then this one there. Kind of snaps into place. It's already kind of in the perfect spot, but it's not fully constrained, right? So I need to add one more. So I'll just do the diagonal there and there. And bam, it's fully constrained. All right, let's see, what other piece can I do? I'll just do this kind of sloped part here. Right, I want it to kind of sit on top. So I'm going to create another constraint there and there. I'm going to add another one here, add constraint. I want these studs to line up. So this one there, and that one, and then another one there, and there. Boom. Is this making sense to everyone? Okay. So now that we kind of have this, there's definitely more parts to come, but we don't have any wheels yet. And most cars, especially in this case, this car as well, they have 4 wheels and tires. I guess if you're not counting the spare tire, right? So oftentimes when you're designing things, you might have some kind of repeating assembly. that is inside another assembly, right? And we'll call those assemblies sub-assemblies, right? I mean, I guess they don't have to be repeating, but you might have, another group of parts that you kind of want to separate or categorize as one unit, right? So for a more complicated car, you might be like, oh, the whole like right suspension of the car is going to be its own sub-assembly. And then you're going to put it into the main car assembly when it's finished, right? So in this case, we're going to just do a wheel and tire sub-assembly, right? So we kind of want this to be separate because it'll make our life easier, because we can create one sub-assembly with a fully constrained wheel and tire, and then we can insert it into our main assembly 4 times without having to reconstrain the tire and the wheel. So to do that, I'm going to create another assembly. To me, like the foundation of this assembly is the wheel and not the tire. So I'm going to insert the wheel. Looks good. It's grounded. And then I'm going to insert the tire. So honestly, in this current state, the tire is kind of in the perfect spot, which is great, but it's not constrained. So I'm purposely going to move it away just so I can confirm that I've constrained it properly when I apply it. So I'm going to add another constraint. If you looked really carefully when I inserted the tire, the wheel is ever so slightly wider than the tire. And I'm a little bit OCD on this, and I really want the tire to be completely centered on the wheel. Honestly, when I'm grading, I probably can't tell because it's so far away. But this is a good opportunity to show you a different constraint type. So there's the center constraint type, which is really useful. So instead of the align constraint, you can use the centering constraint. And then there's even more options, right? So there's 2 different modes, right? There's simple and then 2-face mode. Basically, simple would be used if you kind of have a plane or something in the center that you want to kind of align something to. The 2-face mode is basically allowing you to select 2 outer faces. It'll kind of create a midplane to reference, and then it'll constrain to that. So in this case, I don't really have any plane or face to go off of for a simple 1-face constraint. So I'm going to use the between 2 faces mode. So here, I'm going to have to specify an outer face and an inner face for both the components. So I'm going to do it for the wheel first. So this outer face here, or I guess that's the inner face. This is the outer face. And then I select a corresponding outer and inner face for the tire. So I did that side and this side. And when it does that, you can see, if you look really, really closely, there's this tiny gap on both sides, and they're both equal. So that looks good to me. You'll also notice that, this tire is definitely not centered on the wheel. So you need to add another constraint. So this time it's just going to be a simple one. And select one of these faces, one of these, and then boom. It's constrained. Technically the tire can spin on the wheel, so I guess I can just add another constraint. I'll just align one of these treads to one of these interfaces. But I wouldn't say it's super necessary. But yeah, This looks good to me. Nice, nice full assembly. I'm gonna make sure to save this file as like wheel subassembly. You want to make sure that this is saved because, you know, let's say you created the file, you saved it, and then you added a bunch of parts into it, and then you didn't save it. If you try to insert the assembly or the subassembly into the main assembly, you're going to be inserting like a blank thing, and you're going to be confused. You're like, why isn't the wheel coming into view? It's probably because you haven't saved the file yet. So you want to make sure this is fully saved before you insert it into the assembly, or if you've inserted it already, you need to update it. So yeah, like I guess I'll purposely do it this way, and like I'll update it. You can kind of see that process. So now that I have my subassembly, I can insert it into the main assembly. And again, my subassembly is technically, it should look like this right now because I rolled back the tire, and I'll show you how to update it after. Right, so I'm going to insert the wheel subassembly, though it just looks like a wheel right now. I'm going to add a constraint. In this case, I'll just use this one. So there. And then when you select this, or the face on this one, make sure you be pretty careful because sometimes it'll snap to like points along these arcs instead of the actual center. So when you're looking at it, make sure it's just highlighting the whole face and not one of these points. Because if it is a point, then it'll like spin kind of weirdly. So I'm going to constrain it there. And then I'm going to add another constraint to make sure the wheel doesn't move side to side. In this case, I'm going to select this face. And the corresponding face should be this one here. So if I look head on, it's going to look like that. So cool thing is, you know, I've only constrained it in 2 axes. So, you know, if I want to, I can make the tire spin, and I guess it would spin in real life. So that looks good to me. You know, it's missing the tire right now because I haven't updated my subassembly. So what I'm going to do, I'm going to push this forward. I'm going to save this. And then when I go back to this main assembly, you can see the wheel subassembly has this little like orange or yellowy icon. And it's just saying like, oh, someone, you know, in this case me, like updated this wheel subassembly file. What's being rendered is not the current one. So to fix that, we need to just update it. So we can just right click, get latest version, or I believe you can right click this and then update external references. So if you change like several parts at the same time, it might be easy just to go up here, do that. And you can see when I've updated it, this tire is now in the subassembly. Does anyone have any questions about this?
Yeah. Could you go over the wheel constraints again?
Sure. Like the wheel on the axle?
No, the wheel and the subassembly to the main thing.
As in like, you know, constraining the the wheel to like this piece, right? Or are you talking about the wheel and the tire?
The wheel to the axle thing.
Okay, yeah, I can do that again. So I'm gonna drag the wheel subassembly. So I guess before I enter it, I'm gonna show these faces like individually. It might be easier to see. I'm constraining on, this round part of the axle. And then for the face, I'm making the end of the tire or end of the wheel like kind of go up to this face right here. So there's a little like flat area before it angles downwards. I'm going to select that. And then for the wheel, I'm going to select, one of these round faces, which will kind of go on the axle. And then I'll select this face to kind of butt up against that flat area that I just talked about. So I'm gonna select this one, and then this one. So, it's concentric, which is good. And then I'm gonna add another constraint here. This is when it gets kind of hard to see. But there's that face there. And then we want this face here. And then when you do that, it can't go in and out, but it can still spin. Does that make sense? Hopefully.
Yeah.
Okay, cool. But yeah, that's pretty much it for this assignment. The one thing that you need to remember is you need to apply appearances. So make sure like these are nice and colorful. When you do work on appearances, or when you do apply appearances, please don't make them like gray or black or something. I guess tires can be black, but for your main components, please don't make them like super gray. I may have forgotten to say that for other assignments, but if you can, just please don't make them gray. Just because if I do see something gray, then I might assume that you didn't apply an appearance, and then you might get points off. So, when the colors are pretty bright, it's like really obvious to me that you like applied that color. But if it's like really gray and it's like kind of close to this color, I may like accidentally assume that you didn't apply appearance. So if you can help it, please make it somewhat colorful, or just obviously something not gray or black. That helps me when I'm grading, and you won't miss out on points if it's like obviously not gray. Does anyone have questions about this assignment? I'm not going to finish it, but like, if you're not finished now, that's okay too, because you can do this later as well. No questions?
I'm assuming you have to make it look like the screenshots in the PowerPoint.
Yes, yeah, so your full assembly should look like the complete Lego car in the PowerPoint. So, this is incomplete, but it should look something like this. And just, make sure it's more colorful. This is pretty gray, so more color would be appreciated. But yeah, if you don't have any questions about this assignment, then the homework should be pretty easy for you as well. The homework assignment this week is to kind of create your own Lego car assembly. I mean, not Lego car assembly, your own Lego set. So, it doesn't have to be a car. I mean, I know I have a car here, but you can get creative. You can make other things. I've seen people create houses and stuff like that. You can't see some of these words. I'll move this. But yeah, you can create your own Lego set, preferably something, appropriate. The main thing is you just need to have at least 25 Lego bricks, which usually isn't too hard. Please apply some kind of appearance to your parts. And then, obviously you should be using the constraint tool to kind of place all the parts in the correct spot. If you want to use Lego bricks that are not from, the parts that I provided for this assignment, you're totally welcome to do so. I'll send some resources for that after class, but I can show you some of them now. And I'm showing you this for this assignment, or I'm showing you some of these resources for this assignment, but it definitely applies to stuff beyond Lego. Let's see which repository. I'll use GrabCAD. Okay, so basically, I didn't CAD these Lego bricks, right? You can find pre-made designs online, oftentimes for free, in something that people call like repositories or something like that. So one of the repositories I like is GrabCAD. So I can just show you here. So GrabCAD library is just kind of a place where people upload their 3D models. You can see there's a bunch of different things on here. Some of them pretty sweet. Like, okay, well that's not really appropriate, but like, there's a lot of cool stuff, right? Some people had like cars and stuff like that and put it on here. You can see people are just modeling some standard like piping components. But you can, use the search bar and look for stuff, right? In this case, for this assignment, we're looking for Legos. So when we do that, you can see there's a bunch of different Lego things already here. Please don't just like download one of these and then like submit it. Someone has done that before and I can tell, or like I did find out. So please don't do that. I mean, like, it's just like simple stuff, right? It's 25 bricks, so like it's really not that bad. If you feel like you need to download something and like cheat, just please don't. It just makes me sad, and then you lose out on points. So you're more than welcome to like download these things for yourself and then maybe pull some of the components from it and try to recreate this assembly. But please don't just like upload the step file with like the appearances applied, because like I'll find out, or I can tell. Again, if you should be screenshotting your timelines, and like I can tell when the timeline looks like you've just opened this file and added appearances, like the timeline looks different, so I can tell. So yeah, just please don't do that. It's happened before. It made me very sad. But yeah, there's a bunch of online resources here. GrabCAD is just one of many websites that has stuff for you to download. There's a bunch of Lego stuff here. And then I think I have a couple more resources that I can send you later. But yeah, online repositories are really powerful. I guess going a little bit out of scope for your homework assignment, I find this repository or this website to be very useful. So if you don't know, there's this website called McMaster-Carr. and they have a bunch of different things related to, you know, hardware and stuff like that. So McMaster is, you know, kind of a website that a lot of people go to order nuts and bolts. I know that companies that I've worked for like to use McMaster a lot because, you know, they have really fast shipping and they have like basically everything. You know, you can get stuff like nuts and bolts, but you can also get like really weird things. Like you can buy like microwaves on McMaster. You can buy stop signs, and even like bulk Swedish fish, which is kind of funny. But one of the cool things about McMaster is that for a very large majority of the stuff on their catalog, they do have CAD files for them. So, you know, you don't want to waste your time spending hours CADing a bolt that already exists. You know, bolts are pretty standard hardware, so, you know, you could CAD a bolt, but why do that when you can just download one? So when I'm making like larger assemblies, you know, I oftentimes will download hardware from McMaster. You can download bolts, you can download like bearings and stuff like that. So like, if you have rotating assemblies with bearings on them, downloading them from McMaster is really useful. So you know, you might go through their catalog, you find whatever you're looking for. Let's say, you know, I really, really need, I don't know, a quarter 20 bolt, right? Let's find one. It's 1 inch long, socket head. If I click on this, you can see you can ask for a certain output. So typically I use a step file. You can ask for it with the step, or, you know, for bolts and stuff like that, there's also often an option for no threads. No threads is pretty nice, just because, you know, there's it's a lot more simple geometry for you to work with, and it's less for your computer to render, right? Especially when you have really large assemblies, you know, you're not really looking at the threads of the bolts anyways, so just removing them in the step, you know, makes the bolt a lot more friendly to your computer. So you can just go like 3D step, in this case, no threads. You can download it, and then you can just upload it like we did for all of these parts, right? You can do upload, you know, do your file explorer thing, and then you'll have all that hardware in your kind of data panel or like your project folder. So, you know, bolts and stuff like that isn't super relevant for the homework this week, but, you know, this is a great resource for when you're designing things. I use McMaster all the time. But yeah, I'll send more resources on other places for bricks specifically, but I just wanted to let you know these kinds of resources are out there for you, and can really speed up your CAD process instead of, you know, spending hours just CADing hardware. But yeah, any other questions for the homework? No? Okay. I guess before you go, I'm going to introduce your final project to you real quick. Again, I wouldn't stress about it too much, just because, you know, you can definitely do this. All of the stuff that we've done in class is setting you up to do this, and for the most part, you should be able to do the final like right now if you really wanted to, which is why we're introducing it to you. Basically, you know, your final project is just to kind of give you free reign to test your skills and design anything you like. So, you know, your goal is to create your own CAD model from scratch. Obviously, it can't be something that we've made in class already, you know, so just don't do like the engineering fountain or, you know, any other thing that we've made in class. Um, it must have at least 5 design features. So I guess I talked about this, in week 1 in like kind of the course overview. But now you should probably know, or I would hope you know what a design feature is, right? In this case, you should be familiar with like extrudes, revolves, and fillets, and those all count as a design feature, right? So you should have at least 5 of those in your design. It's a very, very low bar, right? Like I believe for the hairdryer assignment, you're already over 5. So this these like parameters or like these requirements are very, very lax, but they're there just to give you kind of a baseline to work with. But most people usually use more than 5. The last thing that you should have, or the last requirement for the final that I forgot to put on here, is that it should be designed with manufacturability in mind. So we haven't really talked about manufacturability too much in this course, but that's kind of what we're going to be talking about next week. So just keep that in mind. You know, we're trying to design, or the goal is to design your parts to be 3D printed. So, if you know a little bit about 3D printing right now, and you want to start on your final early, then definitely feel free to do so. If you don't really know what I'm talking about when I'm saying designing for manufacturing, hold tight because we're going to be talking about that next week. But yeah, other than that, we're basically done for today. So if anyone has any questions, I'm happy to go over them. But if not, I'll see everyone next week. Questions?